All right. So we're about 2 minutes in. I'm going to get started. First of all, I want to thank everyone for attending our webinar today, The Power of DevSecOps Automation. We put a lot of time into developing some hopefully awesome content and demos. And if you think about it, software is everywhere. The more software we have, the more risks exist. So companies have adopted agility at a rapid rate. Many times, security is an afterthought. But we want to show you how to shift security to the left and why, and to make security more of an enabler and less of an inhibitor. So we're going to focus on automation and integration for web application security and endpoint detection and response relative to DevSecOps. This is going to be demo heavy and slide light. So agenda, it's the obligatory slide. We're going to talk about the business case for automation, particularly around DevSecOps, common DevOps security mistakes. Then we're going to move right into demos. First thing we're going to start off with is what the end result should look like. It is a demo, so it's not going to represent, a Fortune 10 company's DevSecOps pipeline, but it is going to represent what is running on my Mac. Then we're going to move into a demo on web application security and how automation around that is achieved, and hopefully to show you some common attacks so that you can understand how easy it is for adversaries to get through your security. And then last but not least, instead of a demo, we have a daemon. That is the automated EDR testing, which is endpoint detection and response. And then we'll do a quick CDA services overview, question and answers, and surveys. All right, so DevSecOps, it's a pretty simple concept. DevOps is your application development pipeline coupled with IT operations, which effectively gives you infrastructure as code. If you're not familiar with DevOps, we could probably spend quite a bit of time discussing the merits of it and the value of it, but that's not the nature of the webinar today. So with DevOps, you often have continuous integration and delivery, as well as a goal of high quality code. And then security is often an afterthought. So what you want to do with DevSecOps is consider this, that you have DevOps and you want to shift security to the left, which integrates them into the pipeline. So there's some business value there. You're obviously going to save time, focus on innovation. You're going to reduce the rework effort by effectively identifying risks and communicating with the development team and the project team overall, including the business owner. You're going to have an auditable security posture. You're going to improve your agility, and we're going to reduce the tribal knowledge and shadow IT, people trying to get around your security or your operations process, or even your development process for that matter. And then you're going to combat the skills shortage and turnover that's rampant in information security. Seems the smarter people get, the more they're worth and the quicker they leave. So from a DevOps perspective or a CI/CD pipeline perspective, there are some common missing components when it comes to security. And I'm just going to review these very quickly. Each one of these is probably worthy of a multi-hour review and discussion, even a debate in some cases. So security training, are you training everyone, not just the technical people or the developers or your security folks, your operations, but are you training the business owners? Do they really understand how much risk there is to their operation, not just their business, but all the work efforts of the team as well? And then also racing matrix, who does what? In an agile development environment, it's typically no one's really fully in charge. It's really everyone just trying to accomplish a goal and move as quickly as possible. But a racing matrix is critical to understanding how you handle security from an operations perspective and making sure roles and responsibilities are clearly outlined. So RACI, if you're not familiar, is responsible, accountable, consulted, informed, and then there's also an S for support. So threat modeling, are you thinking like an adversary? Adversarial simulation, are you testing like an adversary? And your security architecture, is your data protected? Is it encrypted at rest and in motion? And can you prove it? There's so many data leaks out there and you wonder how they happen, and it's typically misconfiguration. That's probably number one, but it's probably one of the most embarrassing and easily avoided components, but often missing in the DevOps CI/CD pipeline. And then security automation, are you using dynamic, static, and interactive application security testing? There's a lot of free tools out there that work really well. And then there's obviously some commercial tools that work even better if you have the money to buy them. And then the final component, incident and breach response. What happens when your defenses fail? If there's a separation between development, operations, security, so again, security becomes an afterthought. And how are you dealing with that breach? So we're going to move into the first demo. I'm going to talk about what that is. We're going to show you the mature DevSecOps pipeline, which is effectively, from a demo perspective, a Docker container run on Ubuntu with a couple of different containers hosted, one of which is the Marathon application, which is a known vulnerable web app. It was written that way. So I have Ubuntu for core infrastructure, a Docker host, multiple Docker images, and I have a full DevOps pipeline with security integrated. So pulling data down from GitHub, building with Maven, using a few of the security components, which I'll demonstrate, and doing some dynamic testing against it. We give a shout out to Christian Snyder for building the Marathon web application and also for hosting an awesome OWASP AppSec Days training a week or two ago. So thank you, Christian. If you don't know Christian, check out his stuff. Solid guy. Demo summary. So I'm going to move into my demo now. Give you a quick overview. So here's my Ubuntu host, and I have my Docker images running. What they're effectively doing is presenting up these web applications. So I have my Jenkins container and my Marathon application. The Marathon application is just for demo purposes. It was built to be vulnerable, and we're going to show you how the build process identifies those failures in security and also how to fix them. So from Jenkins, if you're not familiar with Jenkins, great free open source tool for automation. It's pretty widely used. It is not the only solution. I have my Marathon application in here as a project, and I've gone through a few builds. Some of them worked, some of them did not. I have all my stages mapped out from preparation, build, code analysis, integration, dynamic scanning, shutting it down, and then producing results. What's really cool about this, or at least what I think is really cool about this demo, is how I've built the security components into it, and also how we've capitalized on the use of quality gates. And I'll show you what quality gates look like here in a second. But first and foremost, we'll just review the builds real quick. So we have our different build. And if we go through and click on each step, if you're not familiar, we'll go through preparation, where we're pulling our data down from GitHub. We're going to build it with our Maven platform. We're going to do some code analysis. And here's where we're pulling in the spot bugs and security tools to evaluate that code. It's a little difficult to see all of that, but just understand that it is happening in the background. After that, we're going to go through some integration testing and startup. This is just preparing the environment. And then we're going to go through a dynamic scanning exercise. And what we're doing there is effectively running OWASP ZAP attacks using curl commands and shell scripting. So we're dynamically assessing the application as we're running. Then we're going to shut down that test and report the results. So shutdown is not very interesting. And the results will be interesting because it will either succeed or fail. And that's where the quality gates come in. So if I were to go back to my application, I have my quality gates, and this is my pipeline. And if I scroll all the way down to this build, you can see all the commands that I was demonstrating in the build process. And then when we look at the results, we're looking to capture that data. And this little line right here is what determines whether or not my build will succeed or fail. And what I have here is a bigger screen that I can show you very quickly, that in the stage phase, if I were to configure my quality gates, I can add the lines to this that say, if I hit this threshold for failures, then I want to mark the build as unstable. In the first pipeline that I showed you here, or in the first build that I showed you, it succeeded. Well, it succeeded, but if we look at the results, it should not have succeeded. This application has a ton of issues, and I'll show you some of them to give you some bearing on what the alerts and the warnings were. So spot bugs, find sec bugs, and find bugs all identified some code flaws, one of which was path traversal issue. And if I go down and step into those into the application and the vulnerability, it'll tell me at this line of code, I've introduced a security vulnerability. So here's what's vulnerable about it. And here's how you go about fixing that. And if I'm in security or if I'm in development, we might say that's a false positive. So naturally, you're going to have someone have to understand what that issue is. And if you don't understand what path traversal is, it basically means that your application has introduced code that exposes data that should not be exposed by traversing paths in your website. So I go and verify that that particular issue is vulnerable to path traversal. And to prove it, here's my Etsy password file from my Docker image. So the code did a good job of identifying the flaw, identifying the corrective action, and we verified that it is not a false positive. So that's just one. If we go back to spot bugs, we can also take a look at some other candidates. Maybe SQL injection as an example. That's a pretty common attack vector. So let's dive into that code a little bit, and it'll take me right down to the application and tell me, here's the vulnerable code, here's the solution. And not only that, here's a number of references. So that, that's security built into my pipeline. Aside from that, we did some dynamic scanning. And if you're not familiar with OWASP ZAP, it's similar to a burp suite or something like that. It went through and built a report and said I have 10 high-risk vulnerabilities, 9 medium-risk vulnerabilities, and 23 low-risk and 1 false positive. So we'll go back down here to just the path traversal, for example, where the other tool also identified the same issue. So you get a general idea. I'm not going to go too far into this, but I've taken my build process and I've built quality gates to say, if I fail the security checkpoint, fail the build, even though my WAR file may be created. Or I have the ability to say, you know what, don't fail, warn. And that's where I've created these different build processes where I get a warning as opposed to a failure, as opposed to a successful build. So it's a pretty interesting process. I'm not going to belabor the point, but with Jenkins and these security components added, it's very easy to get your build integrated with security using free tools. Again, there are many tools that are out there, but if you look at the build times, these builds are typically only a few more minutes longer because of the security that's built into the component. So I showed you spot bugs. I showed you the ZAP process. I showed you the build process and the pipeline and the console output. So if we look at a failed build real quick, in the failed build console output, come all the way down. Here's on my build output, and it said finished failure. And the reason it failed is because the number of detected ZAP alerts is too high. So effectively, this code is too poor to put out on the internet without being at risk of failing. All right, so back to the slides. So what do we show you? We showed you a vulnerable application or an application pipeline in Jenkins following typical DevOps processes or CI/CD pipeline. The things that were added were the code analysis component where we look for common vulnerabilities and exploits and report on them, not just call them out, but tell them, here's exactly where your code is bad. And here are some things that you can do to fix it. We would then take that and automate it even further into some kind of a Jira task or some kind of a bug fix. And then last but not least, we added dynamic scanning to the application so that if you had something like Selenium in front of it or some kind of automated tests, while that's running, you could also do dynamic scans to find things that you wouldn't normally find. None of this replaces a need for security analysts to do their job and review the platform, but a lot of it can be automated consistently as opposed to a point in time result from a pen test. So the last piece is the quality gate. If you know you have security bugs, you can make the decision as to whether to fail, succeed, or warn the entire team, including the business owner, that there are flaws in this code that need to be addressed. And you can make those as part of your backlog, but the longer you do that, you're building up technical debt. All right, so next thing we're going to get into is automating web application security testing. This is a really cool demo. So these slides are going to be quick. We're going to go through the process of planning, creating an attack, testing that attack, and then automating it so that remediation can occur. Once we've identified the vulnerability, the developers have to go and fix it. And instead of paying the pen tester or taking up the time of the resource who found the vulnerability to consistently manually test it, we have them build it and then automate it so that code can be validated for remediation. So the web attacks that we're going to focus on are sensitive data exposure, cross-site scripting, and SQL injection. This is not just your arbitrary cross-site scripting. We're going to take it from cross-site or SQL injection to cross-site scripting, cross-site scripting to sensitive data exposure and actually stealing data. The environment in particular, we use the Juice Shop, also from a vulnerable web application, and Rails Goat. So these are known vulnerable applications. We're not attacking anyone's website in particular. We have Kali Linux in our environment, Splunk, and Jira to show not just the web application security integration, but how the SIM is integrated and how from the SIM, when that alert is created, that we will generate an issue in Jira so that it's automatically added to the workflow. Okay, with that, I'm going to hand it over to Mark Anthony.
All right, thank you. I'm going to grab control here. Should be able to see my screen. So before we get into the first web attack demo, I just want to talk a little bit about the environment we have here. We have a Juice Shop web application running where we have a Citrix ADC firewall setup that's load balancing on there. So we have one virtual IP that is not protected by the firewall, and then we have another one that is, and we have the same setup for the Rails Goat application as well. So there's a protected and an unprotected route, and we're going to deal a little bit with the differences between those. We also mentioned that we have Jenkins, which we have some attack jobs set up that we're going to go into, and we have a Jira project where we're going to create some issues. We have some Splunk. We're going to go into a dashboard and some alerts, but let's go ahead and just start with the attacks. So we're going to head over to Juice Shop for the first attack, and we're going to do some SQL injection. It's going to start out simple, but we're going to go from there and kind of leapfrog off of that and work towards more complex attacks. So just from the main page of the application, we're going to go to the login page. Now, we know that this login form is vulnerable to SQL injection. So I'm going to just copy this SQL injection string. It's extremely simple. They don't try to protect against this at all on Juice Shop. So what this is going to do is it's going to just select the admin user from the database, and then it's going to escape the rest of the query. So it's not going to do any kind of validation on the password or anything. So I've just entered a random password, and it's going to just let me right in. And as we can see here, we're logged in as admin. So we can also verify that we're logged in as admin and we have administrative access if we just go to the administration route of the app, and we've reached this place, so we know that we have admin access. We'd be able to do whatever malicious activity we want. But what we're going to do is, now that we know that the site is vulnerable to SQL injection, we're going to jump off of that attack and use more SQL injection to prepare for a broken authentication attack. So we're going to return to the root of the application, and I'm going to show you this SQL injection string right here. And we're going to attempt to do this on the search field of the site. And I know that this is vulnerable to SQL injection, but they're not rendering the results properly because we're unioning on this query and we're getting results in kind of an unexpected format. So coming from the front end of the site, we're not going to be able to see anything useful. So, but what we can do is we can head to the back end, just go straight through the REST product search endpoint of the API, and we can pass it that same query. And what it's going to do is it's going to just give us the raw JSON output of this. And normally this is the product search API endpoint. So if we scroll down here to before the results from our union, we're just getting like the basic juice items from the products that are on the shop. So what we're doing is we're unioning on that query, and we're grabbing from the users table. We're trying to dump the ID, the email, the password, the one-time password secret. So you could discover this just by trial and error, or you could have some kind of SQL map application that does this for you and discovers what the tables are called and the different columns on the tables. But the users table was just called users, so it would have been pretty easy to figure out at least users, email, password are pretty standard names, ID. So we can see that it's dumping the ID of each user here in the name field, and it's also dumping the email. And then this is what would be the password, but it's in some kind of hash form. And what we're looking for is this user here, worst brought, has, if you remember, we're dumping the one-time password secret here. And he's a user who we know has two-factor authentication set up. So if we wanted to SQL inject and try to log into his account, we would still not be able to get in because the two-factor authentication would stop us without the proper authentication code. But since we have the secret here from doing this SQL injection, we can now use this to jump to the broken authentication attack. So I have a Kali Linux terminal open over here, and we're going to just ignore these parts over here for now. And we're going to be dealing with this quadrant over here where I have the Python authenticator set up. Sorry, if I can just remove this Zoom thing. It actually did get in my way. Shoot. Okay. So here I have the Python authenticator already set up, so we don't have to worry about setting up the environment. But what we're going to do is we're going to make sure that I don't already have an authenticator profile set up for this user, so we can start from scratch. So I'm going to delete the profile I have already. Now we know that it's not there, and we're going to go through the process of adding it. So this Python authenticator basically works the same way that a Google authenticator or Microsoft authenticator works. And we just need to provide a shared secret, which is what we grabbed off this page here. And now it's set up for our account, so we can just say authenticator generate my password, and it's going to start generating these authentication codes that expire after a short amount of time. But if we head back to the login page, and first we have to log out, log in, and we want to log into that worst brought user. So we're going to do the same thing we did for admin, but we're going to specify worst brought as the email. And then we can enter whatever random password string we want because we are bypassing the password authentication there. And so now it's going to ask for our two-factor authentication code. Luckily, we already have that ready over here. And if I'm fast enough, maybe be able to use this one. Yep. So we now got in to the worst brought user. We bypassed the two-factor authentication, and we would be able to do whatever we want with their account if they have payment options set up or anything from there. So that's the danger. That's one of the dangers of a SQL injection attack. I mean, way worse things can happen from that. But we're going to go and talk about cross-site scripting now. So back on the application root, we're going to try executing just a very basic cross-site scripting attack in this search field that we used before. So we paste this in, and what it does is it creates an iframe with a JavaScript source that just executes a simple alert. And Now that we know that it was able to execute arbitrary JavaScript, we're going to see if there's some kind of policy preventing us from making a cross-origin connection. So I'm going to copy this one, which is a little bit more complicated. What it does is it goes out to SoundCloud and pulls a widget to be able to play a song from there, the Juice Shop jingle. And basically, since this worked, we know that we were able to connect to an external site. There's nothing in the, no kind of rule in the firewall preventing that. And so now we're going to use what we know is possible, and we're going to do a more complex attack using that. So we're going to be back on the login page. If I can log out, log in. And I have an account that I use for testing, so we're going to log into that. And I'm using this account because I know I have a credit card set up on there. Not any kind of real credit card data, but just for testing. We have a fake number here. You can see that from the front end, it's actually obfuscated or masked. You can't see the entire number. And this is just a fake name and some date. But so this is our credit card info that we can access from logging into our account. Now, this is going to simulate following a link that might have been given by some malicious actor. We could have received this in a phishing email or even linked somewhere by a friend or something like that. And what this does is it uses that same search field that we use to execute just a regular JavaScript alert. But instead of something simple like that, we're giving it functions and a couple lines of JavaScript code that basically they go to the part in the HTML that has the username, and they grab the username and send it to the malicious server, and it also grabs the document.cookie. So if we execute this, we can see it happening. We have this text box that opens up, and this is just for debugging purposes that I'm showing this. If you really didn't want someone to know that you just stole their information, you could hide this. But basically, this gives us the response of what the server sent back when it received the request. So it received my username, and it also received my cookie. So if we go back over here to the Kali box, we can see that if I just, let me clear this again just so we don't have this character right there. But so we received this request over here. These are the Flask logs from the malicious server. So we can see that we got the request with the username and the cookie, and we logged it to this cookies.log file. So anybody who clicks these links that I send them, they will log their emails and cookies here, so I can have a nice list of them. And what we're going to do is we're going to go over to Kali, and we're going to open the OWASP ZAP manual request editor, just so I have a nice place to put my request. And we're going to, I have a already ready to go request here. And if I paste this in, it has a few placeholders for where you would give the token and where you would give the email. And this is going to make a request to the backend API cards endpoint, which would give us our credit card details. And what we're going to do is we're going to hijack the session of this user who we just got their email and cookie, and we're going to hopefully get their credit card info. So I just need to copy this cookie, paste it over here, and paste that here.
Do you want to show the negative result first?
Oh, you're right. Yeah, so let me show you that it doesn't work if you don't provide the right details. So if we just give the empty request without specifying a cookie and a user, then we're not going to get any details because you have to provide a valid request for it to work. Thank you, Anthony. So we're going to paste that token, paste it there, and then we're going to, oh, shoot. Sorry, I'm messing up here. We're going to paste the token, paste this here, and then the email. So we're going to send that request off, and we got a response that says success, and it's giving me the details from the credit card that we just got. So that's the name that we saw on the page. And this is actually the full number. So it's not being masked in any way. We couldn't see it from the front end, but going through the API, we were able to get the entire thing. So obviously that would be extremely bad for your users. So we could go on and on with the manual testing, but I just wanted to kind of highlight how much effort goes into doing these tests. And you saw how easy it is to make a little mistake, and maybe the test could have given a false result. So what you want to do is automate these tests. So we have these same tests that I've just done. We have them written out in Jenkins jobs. So these Jenkins jobs run Python scripts. They use Selenium testing framework for opening a Firefox browser and going through these same instructions that I've done, but instead of manually, it's automatically. So we're going to look at, first thing we're going to do is look behind the scenes at one of those scripts. And so if I just pull up this terminal I have here, if we look at this cross-site scripting job that I have here, so this is a Python script that runs Selenium. You don't have to worry about some of the setup, but this is going to make a connection to our Rails Goat application, and it's going to basically it's going to set up a new user and do some cross-site scripting on there, which we're going to see in a minute. But basically, we're going to not have this run headlessly so that we can actually see what's happening. So if I just uncomment that, and then I run this on our unprotected Rails Goat app, you'll be able to see exactly what's happening. So it generates a random email and password that it's going to register with. It goes to the sign up page, and it enters this cross-site scripting script in the first name field. Basically, because we know that when that first name is displayed, it's going to run the JavaScript. So we can see that the attack worked there. If I want to just show you that attack manually real quick, we can head over to Rails Goat. We can sign up a new user. We can say demo123@gmail.com. And in the first name field, we're going to just do something like hello. So that script is going to execute. And we're just going to say it's a cross-site scripting test. Let me set up a password. And so this is what I'm talking about. This page, whenever you log in, it displays welcome and then puts the first name in there. But since we've snuck this cross-site script into the database, whenever we launch onto this page and it displays our name, it's actually going to run the JavaScript. So even if we go here, we can go and edit our profile, and we can change the script to do whatever we want, and someone else who views our profile in the application would then execute our JavaScript when they view our profile. So that's what's happening when we run the Selenium job here, but it's happening automatically, and we're able to do this headlessly, so we don't even have to open a browser window. We can just, if I just cancel the job, we can go in here and uncomment this, and then we're able to run it from Jenkins. So if I head back to Jenkins, and we go to the Rails Goat side, where we have that cross-site scripting attack, we can run the protected job. It's the same job that runs, but against two different virtual IPs, as I pointed out before. So this one should not be successful because we're running against a protected host. So when that finishes in a second. So we see it was a failure because we don't want the attack to be successful when we're attacking our protected host. And then the unprotected one is the same thing. We can run it and it should be successful because there's no protections in place to prevent that. So we're going to move on from here, and we're going to look at some of what I have going on Splunk, where I've just set up a basic dashboard here. Let me get the newest results. where we can see what kind of HTTP requests we're getting from hosts. We can see sensitive data exposure attacks on certain packages that we may not want anybody to have access to. And we can see SQL injection attempts. So if I go and I launch a SQL injection attack on JuiceShop from here, so we're going to run this on the protected SQL injection. We're going to run that. And this, I have set up an alert. If we look at the details of this alert, I just made a Splunk app that lets me specify my Jira details. So I have my Jira URL, my service account details here, my project key for Jira for where I want to create this ticket, and then just some kind of summary that I want put in the ticket. And so that alert should have triggered, which if we refresh here, 1807. So yes, that was this minute. And if we head over to Jira, we should see that we got a SQL injection attack. So we're able to get notifications on Jira so that someone can at least acknowledge these and put in some kind of protection, or you could even have it automatically blacklist any IPs that are attacking you. And that pretty much sums up my demo on web attacks and how the process of automating them goes. Anthony, if you want to take back control.
All right, thanks, Mark Anthony. So next we're going to move into automated endpoint detection and response testing. This environment has a lot of tools in place. We try to show you a little bit of variety. What we're using here is some Atomic Red Team, some Red Canary, CIS baselines on protected versus unprotected sites, Jenkins for automation. You get the general idea. Instead of using Splunk in this case, we're using Elastic, or ELK as it's often referred to. And then we have a few other things like Swift on Securities template for Sysmon and WASA, as well as MITRE Caldera. So what we're going to show you from an EDR perspective is how to validate your endpoint detection response consistently. It's pretty common from a security perspective to buy a tool based on hype or industry reports, but inevitably you have to ask yourself, did I test it? Do I know it works? And if I did test it, what does or does not work? So that you understand the true business value of your investment. And more than anything, you're not finding out that it didn't work from your users or winding up on the news somewhere. So we're using the Red Canary 2020 threat report, taking the top 5. Trevor is going to demonstrate process injection, scheduled tasks, effectively living off the land attacks that are very common. And one, how to execute them manually, how to execute them in an automated fashion, and consistently and repeatedly test your EDR platform so that you know security is working as expected. So you're testing your tools, you're testing your sensors, and you're testing your response. All right, Trevor.
All right, thanks, Anthony. So that's a great question. We go down the path of how do we validate our tools. So today we're going to take a look at an approach for validating endpoint security tools, configurations, and event logging capabilities. Anthony mentioned there are many tools in the lab. They all have their own function to assist with making sure our security stack is configured properly, and our event logging doesn't leave us wanting more data after an incident has occurred. Questions we ask ourselves: how can we validate our level of preparedness? How can we identify any blind spots? And how can we test our security stack? One approach would be to simulate adversary behavior. How could we do that in a safe, controlled manner? How would you know what techniques are the most prevalent? So today we're going to demonstrate the use of Atomic Red Team, an open source adversarial emulation project based off the MITRE ATT&CK framework. The MITRE ATT&CK framework is a knowledge base of adversary tactics, techniques, and procedures based on real-world observations. The number of techniques are a bit overwhelming at first glance, but they're organized to make it easy to digest. Atomic Red Team can execute over 500 tests covering over 150 attack techniques, ranging from initial access and defense evasion to lateral movement and credential access. So as a starting point, we took a look at the Red Canary 2020 threat detection report. We reviewed the telemetry that they reported and collected from over 200 billion pieces of data, 6 million investigative leads, and 15,000 detection reports. We'll use this data to select the top 5 techniques and demo those today. So the goal of this demo is to determine if we're protected, determine if we could detect the technique, and make sure we're collecting all the right endpoint data if needed for incident response. So let's take a look here at the lab. I just have a quick, I'm out at the MITRE.org website just to show the MITRE attack framework here, where we can take the techniques and we can find different types of execution or command and script interpreter. And PowerShell, for instance, we're going to demonstrate PowerShell today. So just going through here, we can see the procedure examples. These are any APT groups that might be using these in their malicious activity. But what we want to focus on here is mitigation techniques. Right, PowerShell, you can use antivirus or code signing or disablement, but also the detection. So if you look at every one of the items that we're showing today and you reference the attack website, you can find ways to detect this type of malicious behavior in your own environment. So that being said, let's take a look here. We have a Windows 10 VM that we have spun up here with a default configuration. I'll be using PowerShell to invoke the Atomic Red Team modules. The setup for Atomic Red Team is pretty straightforward. You just clone the Atomic Red Team GitHub repo locally, import the PowerShell modules, and then choose which MITRE attack technique you'd like to run. The tests that are executed are benign. They generally launch calculator, notepad, or command prompt instead of a malicious payload, but they're still effective in demonstrating the attack technique without causing harm to your test system. It's worth noting that the attacks are customizable by modifying the YAML file that's included. So the top technique here was process injection. It's the most prevalent technique found in the threat detection report. It's top of the list due to its usage by the TrickBot malware to execute arbitrary code for defense evasion and privilege escalation. Malicious code is injected into a legitimate process to make it harder to detect or run with elevated privileges. So we'll take a look here at the tests. First one here is PowerShell. So what I want to show is it's T1055 that we're going to use PowerShell for process injection. If we want to look here, we can use the show details command at the end, and it's going to show us what will run when we execute this. And it's the Windows 10 utility to inject DLLs. And we see the actual command here that it'll be using mav inject to inject the malicious DLL. One of the other items here is when you execute a test, you want to make sure you have all the prerequisites in order. So we can just go through here and we can take a look at the prereqs for that test. And we get a response back here that shows that the requirement is to have mav inject on your system. Since it's Windows 10 and it's built in by default, we do meet the prerequisite check. And then finally, we'll get on to actually executing the test. All right, so there we go. We have a notepad process running, and we see that the malicious DLL has been injected, and we see that with this pop-up dialog box. To confirm that, we can go through and we can check Process Explorer. We can come down and find the notepad process, and then we can take a look at the DLLs that were loaded, and we do see the 1055 DLL. So that's the first test that we'll be going through. Let's see. All right. Second test that we're going through is actually scheduled tasks. Scheduled tasks can allow an attacker to perform actions at startup or at a specific time. This allows the attacker to maintain persistence in your system. If a process is closed or the system's rebooted, then the malicious process can be relaunched via scheduled task. Establishing a baseline for automating and detecting of scheduled tasks on your endpoints is a great way to identify this behavior. Let's close out of that and get on to the scheduled task. One of the other arguments I want to show is the show details brief. What you can do is you can take a test and you can identify the test via its MITRE code and then look at the details brief, and it's going to show you all of the different tests that are associated with that type of scheduled task test here. So we're going to pick the second item. And how we can do that is just using the arguments test numbers 2. And what we see here is that the malicious task has been successfully created. So we'll take a look here at the scheduled tasks. I'll just do a refresh here, and we'll see that that task is shown up here. All right. The last bit here is I want to show that the atomic tests can actually clean up after themselves. So if we just copy and use the cleanup parameter, we can execute that. Come take a look at the scheduled tasks again, do a refresh, and you see that the scheduled task has been deleted. So we'll close out of that for right now. The third test we're going to jump into here is remote services, SMB Windows admin shares. So remote admin shares are used for lateral movement and malware propagation. Windows admin shares should be monitored and tuned to eliminate some false positives. So we'll take a look here at this test. All right, so we see basically we were able to map an admin share out to our domain controller. So that takes us on to the fourth item. The fourth most prevalent was PowerShell. PowerShell is used for a number of reasons: execution, remote code download, discovery purposes. It's on every Windows workstation and used heavily by administrators. A majority of macro-enabled malicious documents also leverage PowerShell to download and execute its payload. And it's best to limit PowerShell to admins or ensure that you're logging all PowerShell commands to your SIM. Here we'll go through a test of PowerShell. And we'll see here, I wanted to demonstrate a test that's actually blocked. You see that PowerShell is trying to download Mimikatz from the internet here, and Windows Defender had picked up that and blocked the threat. So that's a positive test. Many of the tests will fail, but that helps you focus on the ones that actually get through here. So we'll focus on test 14 here, where we're calling remote PowerShell. And you can see that we established a connection to our domain controller right here. All right. So the next item here is we have connectivity here for remote file copy or ingress file transfer. Remote file copy is the last technique we're going to show today. It's commonly used to deploy command and control executables to endpoints. Here we can see where bitsadmin.exe, a file transfer utility built into Windows, is used to download a file from the internet. Abusing bitsadmin.exe to download a remote file could be useful if PowerShell was blocked in your environment. So we'll take a look at the test for 1105. And we see here that we're starting a download completed, and we can take a look at that directory. And we see that the file was downloaded. So that concludes the testing piece. So let's take a look at automation. Since we've identified all the tests we wanted to complete, we can leverage the Atomic Red Team remoting capabilities to wrap these commands into a Jenkins job and be able to continuously integrate testing into our pipelines. So let's see here. So we have a Jenkins job. If you're not familiar with Jenkins, Jenkins is a free and open source automation server. So we used it to build this automation adversary emulation. If we take a look at the configuration behind it, we can see that we have a computer at it, we have a password, and we have a username that we're going to use. And then what we can do is take a look here. I have that actually set up as a scheduled task, but we can just take a look at one of the previous builds. And we can see that the same tests were all executed in sequence and that we had a success at the end. All right, and next we're going to move on to Detection. So for detection, we're using Elastic, as Anthony had mentioned. Elastic's an open source search and analytics solution, commonly used as a tactical SIEM. It's good to review the event logs that were created during our testing. We could take this information and create custom alerts, playbooks, automation workflows based on the details found within the event logs. For example, maybe we want to automate that remote file copy. Let's automate the URL lookup to determine if the website is known to be malicious, or check the hash of the DLL to do the same. If known malicious, we can prioritize the investigation and response. It is worth noting that out of the box, the level of detail that is included in Windows requires additional configuration to get this event logging that we have here today. In the lab environment, we're running Sysmon with the Swift-on security configuration. That's going to be able to show us all the parent processes, command line arguments, process details, and the logs are written to the Windows event log and then forwarded to Elastic with WinLog beats. So we'll take a look here at our Elastic instance. And we'll take a look here to see if we can spot process injection in some of our logs. All right, so here we are, we're doing a query. And we see that we have a process create. We see the mav inject was used. We see mav inject was called. This is the DLL. This is the working directory. And here is the PowerShell command that was actually run to execute. So all of this detail would be interesting in an incident response scenario, but we now have this detail that we can use to automate as well if we do some lookups. Take a look here at the scheduled tasks just to see what kind of data we collected there as well. All right, so here again, we have the process name. We have the creator process as command.exe. If we look through the other logs, we see we called scheduled task. We have the task name. We have the process that was going to execute, and at 8:10 p.m. Going down, we can see the same command line that is used to create that scheduled task. All right, and last, we'll take a look at the bits admin abuse to download files from the internet. All right, and here you see, again, we have a process creation command called bits admin. For a transfer, we have the URL of what could be a malicious payload. We have the parent processes that we're calling that. What's also interesting is maybe we want to see who else downloaded that or made that DNS request. So we can go out and query to see what DNS requests were made to that GitHub user content as well. And we see that service host here was making that request. So the identification and testing process is important to building a mature security program and ensuring you're getting the most return on your security investment by validating your configurations. We talked about the top 5 most common attack techniques so that you can validate that you're collecting enough data related to these types of attacks. The tests we performed what would be considered living off the land, techniques that use built-in tools that already exist in a Windows environment and are trusted by the operating system. And it's relatively easy for an attacker to change hash values or IP addresses or domain names, but it's extremely difficult to change the tactics, techniques, and procedures, which is where we spend our time testing today. So that concludes my demo. We'll send it back to Anthony.
Thanks, Trevor. All right, so let's just review pretty quickly what we talked about today. It's a pretty simple concept. You have DevOps, you have your security team. How do you get them more integrated into the process? And automation is the key because you don't want to have to wait for meetings or wait for results or wait for a pen test or a CapEx for that pen test to be approved. There's a million obstacles when you throw security into the mix. How do you deploy quickly, high quality code, not just on the development side, but also on the hosts that are running that code? So if you have Linux or Docker containers, Kubernetes, whatever you're running on the back end, the host level security is often overlooked. So you need to move security to the left, simply put. You need to train everyone on security. You need to think and operate like an adversary. And then not just there, you need visibility across the board. It shouldn't be a secret when you have a vulnerability to the team. Obviously, you don't want to advertise that publicly. And then aside from visibility, how do you automate? And we showed you a bunch of different ways to automate things. We could obviously show you more. We're trying to be respectful of everyone's time. And then last but not least, do you have the data needed for an effective response? If you're not looking at your endpoints, that's servers and workstations, even phones in some cases. If you're not collecting that data and you're using the out-of-the-box functionality or buying third-party tools and you're not seeing what you're supposed to be seeing or testing to verify that you are seeing what you're supposed to be seeing, there's probably a lot going on that you're missing. So we wanted to make sure we pointed some of those things out and understand that you can introduce security into your DevOps or even your just day-to-day IT operations through automation. And last, we're going to go through CDA services. This is probably the least interesting of all of them, but most interesting to me. Why CDA? We have the experience, incredibly flexible. We do not operate on strict scope because it's rare that we go into an environment where scope does not change. We are capable, but we're very flexible. Accountability, when we're assigned the task, we own it. And we're obviously committed to the customer success. And last but not least, we actually get it done. We don't talk about doing it. We make sure that we hit the mark on time. So common asks from our customers for a DevSecOps perspective are obviously staff augmentation, project-based services or managed services. From a staff aug perspective, we bring the right resources that are day one ready. We're not just going out there and recruiting like the typical process. We are finding the right people, training them, and making sure that they can prove their skills to the customer before we put them on site. So web app security engineering, automation engineering, compliance, and naturally application delivery across the board, because that is typically the goal. Security is a piece of that. Launching new applications, building your threat modeling process. If you don't have one today, you might want to do it in the form of a tabletop or even using something like Microsoft Threat Modeling Toolkit or any other free toolkits that are out there. And then defining a security baseline, like what does good traffic look like and what is an anomaly, because there are always going to be novel attacks. And from a managed services perspective, if you don't have the talent or you have trouble keeping the talent, we can come in and manage the entire platform end to end. We can help you get it up and running and hand it off, or even just providing managed services for operations support, boots on the ground. All right, so now we're open for question and answers. And just to point out, there will be a survey delivered afterwards. So we appreciate your time and we welcome your feedback. That's really all we have here. Brian, did you want to add anything?
I do have a couple questions. Here's a good one. Where is the best place or best means of getting started if an organization is looking to implement DevSecOps into their process?
So the best place to start, that's the question?
Yes.
It's a tough one. We take the people, process, platform approach, which I know sounds somewhat cliche. The first place you want to start is with your people. Are they trained on security? Are you doing threat modeling? Are you thinking like an adversary? So I'd start with the people. Make sure you understand where your gaps are. Here's what you need, and that's something that we could provide. And then we can help you assess what you have and help you put those pieces in place. After you assess the people, we move on to processes and say, do you know what your processes are? And where are the high value processes so they can be prioritized first? In short, so you get the bang for the buck. You might wind up with a list of 200 items that need to be addressed. So I wouldn't say hit the low hanging fruit first. I would say hit the ones that have the most value or have the most vulnerabilities. And then last but not least, after you have the people flushed out and the processes mapped out, documented, and threat modeled and prioritized, then you start to pick your platform. And your platform, there's so many tools out there that work, many open source and free, and then obviously third-party tools that you have to pay for, which are sophisticated, but not always as far ahead of the curve as you think. I mean, when you do red team, blue team's almost always on the losing side because they're playing catch up. So hopefully that answered the question.
Thank you, Anthony. Another one is, how can an organization get the most value out of implementing a DevSecOps process?
Most value. I would go back to my first answer, and I would talk more about prioritization. Identifying your gaps and then prioritizing them. By prioritizing, you're going to see value immediately, and then you're going to be able to build on that value. And through the process, you'll also attain value, but because the team will become more and more knowledgeable. And when they see that it's possible and see how effectively it can be implemented, you're gonna see it happen just as quickly.
Okay, great. Here's another one that just came in. What's the most common challenge you see? And I imagine that's probably in regards to implementing, DevSecOps.
Yeah, I mean, the greatest challenge is typically, again, starting with people, understanding the culture, understanding the teams, and then understanding that development wants to move quickly, right? And they should. That's how you stay cost competitive. That's how you establish cost leadership and have innovative products for your customers. But security needs to get moved to the left, and moving security into that pipeline, even between operations and development, is not usually a simple transition, because if you have archaic ways of handling security, or you're not up to speed on the latest and greatest technologies to keep things moving quickly, but also securely and efficiently, then there's going to be pushback. So people are typically the first challenge. And that's a culture shift. Anytime you change the culture, you typically run into some obstacles. But as far as technology, there aren't quite as many. I'll go back to one other thing too, is Mark Anthony demonstrated, a protected application versus an unprotected application. If you have the mindset that you bought a product and that product will protect you regardless, you obviously have some kind of blind faith issue. And blind faith in products is often the result of too much marketing. And that's a challenge as well. You get people that have a lot of faith in their security products, and most of them are pretty good. They're really good. But there's always that patient zero. There's always that first target that gets owned. And if you're not testing consistently, that's a challenge. So getting past that is also difficult. I'll give you an example. Web application firewalls. We use NetScaler in this case, and NetScaler does a great job of protecting, a lot of things that can be identified using snort signatures, right? Everybody's using snort for their signatures, but snort signatures have to be updated. If you're using some kind of interactive Node.js or anything that's delivered behind what are called start URLs, it may not protect you against those things, or your REST APIs. Anything that's operating in a streaming fashion is not going to be protected by a typical signature. So development is moving way faster than security. Adversaries are moving faster than security. And convincing people of that is difficult without, attacking them. So sometimes, there's the culture shift of moving security left, and then there's the other challenge where you think you have enough technology because you bought a product that was sold to you probably with, the foot firmly on the gas. Hopefully that answers the question.
No, thank you, Anthony. That's great. There's one other question. I think this borderlines on the value question. Where's the biggest bang for the buck?
Yeah.
And if you've already answered that, I understand, but I figured I'd ask it since somebody had asked.
I'd say the biggest bang for the buck is implementing some kind of automation platform and running an assessment. Running the assessment on your code, static, dynamic, interactively. So if you're doing static application security testing, dynamic application security testing, or even interactive application security testing, as opposed to or in addition to your point in time pen tests, which are effective, your biggest bang for the buck is getting that assessment done so that you know where your risks are. And then from there, you can come up with a plan to remediate. It's rare that you're going to have an application that is 100% secured. So situational awareness is the short answer.
Okay. I think that wraps up all our questions. Thank you very much, Anthony. I have posted the link to our post-webinar survey in the chat box, and we'll also be sending that around through email as well. So, we value everybody's participation and their feedback, and if you could please fill out that survey, it'd be much appreciated. And
Thank you,
all
everyone.
I have, Anthony. I'll let you wrap it all up.
That sounded like a wrap to me. Thank you, everyone. Have a great week. I know it's not Friday yet, but it could be in your mind. So hopefully you enjoy the day, and we appreciate your time. Have a great one.
Thank you.